Hi, good afternoon everybody. Welcome to another episode of Math with the Thinker's Cap. Okay, my name is Mr. Tam. Okay, in today's lesson we're going to discuss a topic that is usually taught in JC1, right, under the topic of summation or series. Alright, and this method involves the use of the method of difference, right, where some of the terms will cancel out each other, resulting in the remaining terms being the result of the whole summation of a series. Let's take a look at this example, right, to see how we can consider the use of method of difference in finding the summation of this particular series, right? So in this case, we have got a series where I have the summation of n equals to 1, right, all the way to the n term, okay, and the term formula is actually 1 over n, n plus 1, and n plus 2. Alright, okay, we are asked to consider the difference between the two terms, right? un and minus un plus 1. Alright, okay, where my un is 1 over n, n plus 1, and the other term is n plus 1. So I'm just going to replace n with n plus 1. Alright, and I'll get n plus 2. Alright, so in this case I'm going to simplify these two fractions, okay, and by finding an LCM, the LCM will be n plus 1 and n plus 2. Alright, so in this case I've got multiplied by n plus 2 over here, and minus multiply by n, right, and the outcome will be 2 over n, n plus 1, and n plus 2, right? So as you can see, the outcome here is related to the term over here, right? Just that we have an extra 2, right, times 2 at the top, right? So I'm going to rewrite this, right, so that I can express the term formula in terms of the difference between the two terms, and that will be half un minus un plus 1. Right? Okay, so in this case now we can redo our summation, okay, by considering these two terms, right? So the summation of n equals to 1, and I'm going to rewrite this for easy reference. Right, okay, I'm going to write in the first term, which is what? un minus 1 plus 1, which gives me 2. Alright, and I can continue, right, to write, okay, the series, okay. The next term will be what? When n equals to 2, I've got u2 minus u3. The next line will be u3 minus u4, so on and so forth, right? Okay, and you realize that there are some terms, okay, u2 and minus u2, they will cancel out each other. All right, okay, so I'm going to write the last line as well, right? So the last line will be plus un, right, minus un plus 1. Alright, and in this case my un will be cancelled as against the previous line, right? You expect to see another line here, okay? So for the sake of clarity, I'm going to write this line, okay, un minus 1 minus un, and this term actually will get cancelled out as well, right? So whatever is left is actually u1 and minus un plus 1 term, right? Okay, so in this case, okay, I'm going to put the 1 inside to find out exactly what term is that. So that's half, okay, 1 over 1, okay, times 2, okay, minus 1 over, okay, n plus 1, okay, and then plus 2. Right, I'm going to bring the 1/4 in, that will give me half in rather. okay, 1/4 minus half 2 n plus 1 and n plus 2. Right, and there you have it. Right, and this is the outcome, okay, of the summation from the first term to the nth term for this particular series. Right, so in my next example, right, I will explain how to make use of this result, okay, to deduce the sum to infinity. In this second installment on the lesson on the summation of a series, right, we're going to explore how we can make use of the original results, right, to deduce the sum to infinity, right, and to find out how another series, right, that is related, okay, by the movement of one of the n, right, to n plus 1 or n minus 1, how we can make use of the previous result, right, to deduce, right, the new result without having to redo the whole series again. All right, okay, let's take a look at the previous result that we have obtained. All right, so in this case, the results that we have obtained is actually summation n equals to 1 all the way to my n term over here, okay, 1 over n plus 1 and n plus 2, right, and this is the result that we have obtained, right, from the previous lesson. All right, okay, so in part 1 now we're going to deduce, right, what happens if there's a sum to infinity from the second term to the nth term. All right, okay, so in this case, okay, n equals to 2 and to infinity, okay, 1 over n plus 1 and n plus 2. All right, okay, so now we're going to start by changing the term, right, okay, instead of 1, I'm going to change to 2 now, right, meaning the first term is going to be 2, right. So in other words, I'm going to make use of this n term over here, n plus 1 and n plus 2, right, and I'm going to minus off my first term. All right, so the first term is when n equals to 1, so in this case I've got 1, 2 and 3. All right, so this is the first term. So by subtracting away the first term, basically I'm starting the summation of series from the second term. All right, okay, so in this case I've got 1/4 minus 1 over 2 n plus 1 and n plus 2, right, this is obtained from our previous results, okay, and minus 1 over 6, right. So in this case the outcome would be 1/4 minus 1/6, right, so my LCM will be 12, right, so I've got 3 over here and then minus 2, minus 1 over 2 n plus 1 and n plus 2. All right, okay, and that will give me 1 over 12, 2 n plus 1 and n plus 2. All right, so as my n approaches infinity, because basically that's what the sum to infinity implies, I'm going to sum all the way, right, where n is infinity, right. The second term actually is a fraction, right, which contains n as a denominator. So in other words, this whole fraction will become very, very big at the denominator, so much so that my 1 over 2 n plus 1 and n plus 2, right, will tend towards 0, and therefore my whole sum to infinity, right, n equals to 2, n plus 1 and n plus 2, and that whole series, okay, will tend towards 1 over 12. All right, so this is the result, right, for summing to infinity, where we find out what happens when n approaches infinity. Right, so that's for part 1. Okay, for part 2, we are asked to find out, okay, the summation of this series. Okay, n equals to 1, n minus 1, right? 1 over n plus 1, n plus 2, and n plus 3. All right, so if you take an observation, right, about this series and the series that we have found earlier, right, the term formula seems to have a slight difference, right? Okay, so my n now becomes n plus 1, n plus 1 now becomes n plus 2, and n plus 2 now becomes n plus 3, right? So in other words, we're going to make use of this this result, right? The previous result, okay, by moving the term back by 1, right? So the outcome of moving the term, the n, backwards by 1, right, will result in the first term and the last term moving forward by 1. All right, okay, so if this moves backward by 1, which is n plus 1 become n plus 2 become n plus 1, and then plus 3 will become n plus 2. All right, okay, my starting term will move forward by 1, so my n will become 2, and my n minus 1 will become n. All right, okay, so basically I have a sum, right, okay, where I'll get 1 over 4 minus, okay, 1 over 2 n plus 1 and n plus 2, right, and minus away the first term, right, and this is exactly what we have done, right, for part 1, right, so we do not need to redo the working again, right, so this is the result that we are expecting to get. Okay, 1 over 12 minus 1 over 2 n plus 1 and n plus 2. Right, so I'm writing out this part for clarity to explain to you that actually this outcome is exactly the same as this outcome, which we have found in which is exactly the same as what we have found in part 1 as well, en route to finding sum to infinity starting with n equals to 2. Right, okay, I hope that you have found this lesson useful in helping you to understand, right, the summation of a series using method of difference, and how to make use of the first result, right, to find another series where the n is replaced by either n plus 1 or n minus 1.